Hello, welcome, welcome, welcome. Can you all hear me? If you can hear me, please put your name in the chat. Please put your name in the chat if you can hear me. If you're live, please put your name in the chat. Ilang, are you live? Letabo, are you live? Arushi? Ilang? If you're live with me, okay, please put your name in the chat so that I know who is live with me. Okay, so we are going to so I'm going to switch on to chapter 2 tomorrow. And from tomorrow we'll be going through chapter 2. Today we're going to call it Question Friday. So Question Friday, we are doing past papers. Okay, Ilang, I can see you. We are just going to do for the last round. We're going to do all the past papers that we can find, all the paper ones that we can find. We'll do questions on converting from binary to hexadecimal, from binary to denary, from denary to hexadecimal. So this is Question Friday. Let's quickly do and let's prove that we understand this chapter and we can move on to the next one. So I expect to meet you again tomorrow. We'll talk in the group and we'll finalize what time, okay, what time we're going to do it. But right now we want to do conversions between binary and hexadecimal, hexadecimal and denary, these conversions, okay? Let's quickly do it. So let's see how it goes. We'll be moving as fast as we can. Sorry. I'll start with October, November 2023, paper 1. October, November 2023, paper 1. Right. All right, so here's the register, and they said that blah, 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 blah. Register 1 stores the denary value 10 as binary. Register 2 stores the denary value 50 as binary. Okay, so the parking lot costs $10.50. So give the parking lot cost that would be displayed. So anyway, register 1 is binary, but you should be able to convert it to denary so that we see how much it would be. Then this one again, denary. These would be the cents. So these are basically dollars. Okay, they're trying to make the question look hard. These are dollars, these are cents. We know that register 2 is for cents. Okay, and register 1 is for dollars. So we are converting to denary basically, from binary to denary. So let's put that. Now, here's what I just want you to know. When you're converting from binary to these numbers, it's very, very easy because here is the idea. If you are going to be converting from binary to denary, then you're going to put a continuous thing. It's going to be a continuous thing like this. Let me show you, then we're going to do it. If you're doing binary to denary, okay, if you're going to do binary to denary, for whether you are doing denary to binary or binary to denary, you need to have this one. This power of these 2s, 2 to the power of 0, which will be 2. Then you say, okay, 2 to the power of 0, which will be 1, I mean. Then you say 1 times 2, you get 2. 2 times 2, you get 4. 4 times 2, you get 8. 8 times 2, you get 16. 16 times 2, you get 32. 32 times 2, you get 64. 64 times 2, you get 128. These are you're going to use this all the time. You're going to be using this. If you're moving from binary to denary or denary to binary, you're going to use this. Then when you're going to do binary to hexadecimal, okay, binary to hexadecimal or hexadecimal to binary, for both of them, you are going to use this number line, 8421, then 8421. Okay, that's all you got to know. If you know this, you can do any conversion. If you know this, you can do any, I don't even care. If you know this, you can do any conversion, because if they now come to you and say, convert from denary to hexadecimal, you first go to binary. Okay, you say denary to binary, then from binary you go to hexadecimal. If they say come from hexadecimal to denary, you first say hexadecimal to binary, then binary to hexadecimal. We know that whether we are coming from binary to denary or from denary to binary, the moment we have those words, binary and denary, we need this one. We are going to quickly put this box. This is our working space, and we're going to use this. Okay, the moment they say binary to hexadecimal or hexadecimal to binary, we are going to use this one. This is the one we're going to use. Okay, can you all see? Can you all see my screen? That is what we're going to do. Please don't let me down. So now let's do this. So we're going to see the word binary and denary. So basically we need to have that 1, then 1 times 2, 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 64 times 2, 128. Okay, this is going to be what you have, 8421, something like this. Okay, so here we do, then we have black. Now let's go for it. So what you're going to do is you're just going to take that exact number, you put it in here, 1 0, exactly as it is, 1 0. So we've taken way too much space now. Let's make it smaller. Okay, we've taken, because we're going to need to have 2 numbers, so we need to make it smaller. Let's go. I'm counting on you. We can do this. So we make it small like this. We make it small like this. So it's going to be like this. Then you put that number. So it's going to be 3 zeros in front. So 1 0 0, and then it has a 1. Then it has 3 zeros. Okay. Then it has another 1. So it'll be like this. So now all we are going to do, we just take the values. We just add the values that actually had a 1 on them, which is 16 plus the other value that had is 1, so you get 17. So this is going to be $17. Now we are putting the cents. What do we do for cents? The very same thing. Okay, you do 1, then times 2, you do 2, times 2, you get 4, times 2, you get 8, times 2, you get 16, times 2, you get 32, times 2, you get 64, times 2, you get 128. Then we are going to do this. We are going to change. We can change from binary to denary or from denary to binary by knowing this one. That binary to denary or denary to binary, it needs this from 1 all the way to 168. You need to have it. Make sure you have it. Okay, I see you, Ilang. Welcome, hey? Well done. So now let's put this. It's going to be 0, then 1, then 0, 0, 0, then 1, 1, then 0. Okay, this is going to be what we have. Now let's convert. Where do we have a 1? On a 64. Plus, where do we have a 1? On a 4. Plus, where do we have a 1? On a 2. So 64 plus 4, 68 plus 2, 70. So it's going to be $17.70 because this is 70. And you're done. Okay? So denary to binary or binary to denary, this one, it doesn't give us any challenge at all. They need to find harder ones, okay? Way too easy, man. Way too easy. Way too easy. Now let's do this one. This is the price now, and they're saying give the binary for it. Okay, no problem. So we start with 14. What do we do? Before we even talk about 14 or anything, we need that number line of ours. Let's put it. So it's going to be 1, then times 2, that's 2, times 2, that's 4, times 2, that's 8, times 2, that's 16. Okay, we need to start here. 1, then times 2, that's 2, then times 2, that's 4, times 2, that's 8, times 2, that's 16, times 2, that's 32, times 2, that's 64, times 2, that's 128. Okay? So here it is, 32, 16, 8, 4, 2, 1, like this. Because this is denary, okay? This is a denary number, and we are converting it to binary. So we need this one. This is the type that we want. Either way, now let's put, so what do we have? We start with this. We're doing for 14, okay? Then we'll do for 98. So we do for 14. So we are starting with 14. So what you're going to do is you are going to put 1 on the number, the biggest number that is less than 14, okay? So we are going to move until we get to a number that is smaller than 14. We move. So 128 is not smaller than 14, so that's 0. 64 is not, that's a 0. 32 is not, that's a 0. 16 is not, that's a 0. 8 is, so we'll put a 1 on 8. And once you put a 1 on something, you go and divide by it, okay? You go and divide by it. 14 divided by 8. Remember, you have no calculator, okay? 14 divided by 8 is 1. Then you say remainder 6. Okay, 14 divided by 8, it will be 1. Then you get 6. You remainder 6 because you say 14 minus 8 to get that remainder. Then that remainder, you now divide it. Okay, so we are now going to work with 6. For 6, we are going to put zeros until we get a value that is less than 6. In here, we check the next one, 4. 4 is less than 6, so we put a 1 on it. Once you put a 1 on it, you divide that remainder by the 4. So it becomes what? 6 divided by 4 is 1, remainder 2. 1, remainder 2. So now we are going to put zeros until we get to a value that is smaller than 2 or equal to 2. We go to the next one. What is it? It's 2. Oh, 2 is equal to 2. So we can say, we now say 2 divided by 2, we'll get 1, remainder 0. So we would have put a 1 here, by the way. And it's a remainder 0, so you might as well put a 0 here. So that means you now know what it is. It's 0, 0, 0, 0, then 1, 1, 1, 0. That's how you do it. Okay? Give me 1 sec. Okay, so here that's like it. And now we'll do for this one, eh? We are doing for 98 now. So for 98, it's another denary. So we put 128. You started 1, so it's 1. 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128. So we are going to put it like that. We will put it like that. Okay? That's what we do. All right, so yes, here you put the 8421, okay? Then now what would you do? You would say 120, this is 128. Come on, I know, I trust you people. I trust you a lot. Ilang, I know you can do this. So what you're going to do now, you'd say, okay, what do we have? We have a 98 now. Wow, there's going to be a lot of work there. Let's start. Is 128 smaller than 98? It is not, so you put a 0. Is 64 smaller than 98? Yes, it is, so you put a 1. Then you're going to say, what is 98 divided by 64? This is going to be 1, remainder what? You say 98 minus 64. 8 minus 4, that's 4. 9 minus 6, that's... So it'll be 1, remainder 34. Now we'll go to the next number, 32. Is it smaller than 34? Because we are now looking at the remainder. We are now working with the remainder. That's 34. Okay, is 32 smaller than 34? Yes, so we put a 1. So here we would say it would be divided by 32. And you get a 1, remainder 2. Because that'll be remainder 2. 34 minus 32 is just 2. So now we go to 16. Is it smaller than 2? No, so 0. 8, is it smaller than 2? No, so 0. 4, is it smaller than 2? No, 0. So we are working with that 2. 2, is it smaller than or equal to? It is equal to 2, so we can use it. So we'll put a 1 here. And you get a 1, remainder 0 here. So we have a remainder 0, so we might as well put it like that. So now what would we have? A 0, a 1, a 1, a 0, a 0, a 0, then a 1 and a 0. This is going to be your final solution, and you are done. And you are done. Is there anyone with a question here? Is there anyone with a question? Anyone with a question? No question. Now let's get this other one. By now we know what happens. Once they give us hexadecimal, we can do it. Look at this big hexadecimal. They're trying to get it. Too late. Way too late. We know that for hexadecimal, we'll be saying 8421, 8421, 8421, 8421. Hexadecimal and binary, that's how you do it. Okay, so we're going to have this is a 1. Let's write that whole thing. 1010. Then you put 0. Okay, it's 1010. You put 4 at a time. Then what is the next 4? 0000. So the next 4 0000. Then the next one 0111. So the next one, okay, 1 2 3 4. Then these ones 1 2 3 4. Then these ones 1 2 3. Oh, so that means we actually this here you need a 0 there. 2 minutes. Let's count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Let's see. 1 2 3 4. Okay. Put a line here. 1 2 3 4. You put a line here. 1 2 3 4. Wait, 1 2 3 4. You put a line here. All right. So it's 1010. Then 0000. Then 0011. Then 1101. There we have it. So this is going to be what we have. This is way too easy. Way too easy. Way too easy. Way too easy. Okay. Way too easy. They should have done better. So anyway, we can put them on second. You should always put them on line number 2. Okay. 1101. You put them on line number 2. 0011. Put them on line number 2. This is 0000. Then here it's 1010. So what we'll do, we would come and say 8421. Here 8421. Here 8421. Here 8421. Remember hexadecimal, it's 4444. Okay? Because one decimal is 4 binary. One hexadecimal is 4 binary. So this is 8 plus 2. That's 10. Remember 10 is A. So this will be A. Okay, because it's a 10, which is an A. This one will be 0, so it is 0. Then here it is 2 and 1, which is 3, which is still a 3. This is 8, 4, 2, 1. So 8 plus 4, that's 12 plus 1, that's 13, which is D. Okay, A is 10, B is 11, C is 12, D is 13. So it will be a D. So your hexa ticket is actually A03D. This is your hexadecimal ticket. That's how you convert to hexadecimal, and you are done. You just do these individual. And you're done, okay? So, we don't actually explain why I did it. No, we're not explaining anything. We're just doing the calculations. So here we are done. Which paper was this? This was paper 1-1 for October, November 2023. It gave us a lot of marks for doing it. So paper 1-2 now, October, November 2023. Paper 1-2, let's see, okay? Let's see this one now. Paper 1-2, they say is here, we have it, says, a register stores the binary, then they say give the denary for the binary stored in here. Denary! Are you talking about denary? You know, you say 2 to the power of 0, that's 1. Okay, any number to the power of 0 is 1. Then you say 1 times 2, you get 2. 2 times 2, you get 4. 2 times 4 times 2, you get 8. Times 2, you get 16. Times 2, you get 32. Times 2, you get 64. Times 2, you get 128. So this is going to be 128. Okay? Now let's put the values. Let's now add them. Wherever there is a 1, that's where we are putting. Okay, that's where we're putting. So here, what is it? If you want to rewrite, you can rewrite on their working space. If you want to say the working space will be 1 is on 128, so it'll be 128 plus another one is on 64, so plus 64 plus another one is on 32. Okay, then another one is on 2. Another one is on 1. So now we have to add these numbers. That's where it's going to be nicely challenging there. So you better be careful. We can try it. What is 128? 128 plus 64. 8 plus 4, that's 12. 2 carry 1. 8, 9, that's 192. Then you now say, what is 192 plus 32? This 2 plus 2, that's 4. 9 plus 2, that's 12. 12 carry 1. 1 plus 1, that's 2. That's 224. 224 plus 3, because 2 plus 1 is 3, right? Plus 3, so you say 224 plus 3, you are going to get 227. So the answer here is 227. There you get your 1 mark. The most important thing is to know, okay? this is exactly this can help. You understand? This is exactly what you need. There we go. So yeah, that is how you do. The most important thing that I want. Oh, hi, Shuhaib. Hi, how are you? The most important thing that I want you to understand here is that if we are doing denary, the number line, the system we have is this one. It goes all the way to 128. The moment you see the words denary and binary together, do this one. Then the moment you see the words hexadecimal and binary together, you say 8421, 8421, 8421, 8421. That's what you do the moment you see the words hexadecimal and binary. Now, you say to me, what about if I see the words hexadecimal and denary? They don't work together. If you see hexadecimal and denary, they don't work together. You have to say hexadecimal to binary, then binary to denary. That's what you do. Or you say denary to binary, then binary to hexadecimal. So you have to go through binary. And we know how to do when we have binary. It's so easy for us. It's so easy. We can handle it, okay? We're not afraid of it. So let's go to another one here. Give the hexadecimal for the binary. Oh, thank you. That's not a problem. I'll put my binary on the next line. Here's the binary that we have. Remember, it is 111. Okay, for binary to hexadecimal, that's just so easy. It's 1110, then it is 0011. So what we are going to do, we say 8421. Okay, 8421. And what do we get here when we say 8421 on this one? You can do with your pencil and you can box it up. So then we have a 00, okay, 0011. So it's again 8421. That's the number line for this one. Okay, that is the number line for this one. So what are we going to do? 8 plus 4, 12, plus 2, that's 14, which is going to be E, because 15 is F, right? So that's E. You can do A is 10, B is 11, C is 12, D is 13, E is 14. So here it is 14, so that's an E. Then here we say 8 plus 4, there's a 0 on 8, there's a 0 and 4, so we don't care. Then 2 and 1, so this is 3. So that means your solution here is E3. Your solution here is E3. And you move on to the next. You messaged me through WhatsApp and I didn't reply. Shuhaib, I didn't see your message. Let me look. I don't know how. I haven't seen it. Message me right now. So, oh, Instagram. Okay, let me check. I'm going to go on Instagram just after the lesson, okay? Then I'm going to check Shuhaib and then I'll see you. Sorry for that, okay? I'll go on Instagram, then I'll respond. Now let's see here. This is going to say a logical shift. Okay, I'll teach you logical shift, but let's just finish on binary. Okay, let's just finish on binary. I'll teach you these two, okay? How to do negative values and how to do a logical shift. Just put it on the star. I want to first make sure we are done with the part we are doing right now. So that's more work for us tomorrow, okay? That's more work for us tomorrow. I think we should go live at 10 in the morning. If not at 10, then it's going to be at 2 Central African time, 2 p.m. No problem. Now here, the number 00 is added to this number. Where's one more? Where are the things? Don't worry, I will do them tomorrow. Which paper is this? I should put a star on it. I want to do it tomorrow. I love it. Paper 1, 2 is going to teach you a lot of things. But let's finish with what we have been doing so far. Paper 1, 3. There we go. This is the last one, okay? I'll do 3. Then now I have to give you work you try. I think you understand this by now. So here, convert the binary to denary. Oh, to denary, really? Okay, so let's put that binary number there. It's going to be 1 0 1 0 1 1 1 0. Then you put 2 to the power of 0, that's 1, times 2, that's 2, times 2, that's 4, times 2, that's 8, times 2, that's 16, times 2, that's 32, times 2, that's 64, times 2, that's 128. So this is going to be, these are the values. Can you see them? So now we are going to say, because it says binary and denary, so we know the number line for binary and denary is this one. It goes all the way to 128, right? So let's not make it neat. Try to make it neat, okay? Try to make it neat. Try to make it neat, something like this. There we go. So now, wherever, we're just going to take the values where there is a 1. Those are the only values we're going to take. There's a 1 on 128, so we say 128, okay? There's a 1 on there. Then there's a 1 on 32, so we say plus 32. There's a 1 on 8, so we say plus 8. There's a 1 on 4, so we say plus 4. There's a 1 on 2, so we say plus 2. So this is our working, okay? So now let's do it. Would say, let's start 128 plus 32. This is the hard one, okay? That's 10, 0, carry 1. That's 5, 6. That's 168. This is 168. Then we add 8. That's 176 plus 4. That's 180 plus 2. That's 182. So you get 182. You have no calculator, so you need to be able to work it out. You can even do it with a pencil somewhere, wherever. Now here they're saying convert the binary numbers to hexadecimal. Come on, again? Really? You think we don't know? 1010. Then we say 1110. Okay? Then we do 8421. Then we do 8421. So this is 8 and 2. That becomes 10, and 10 is A. Okay? Because remember, it's 0 to 9. Then when it's 10, you say A. When it's 11, you say B. Those are the rules. So here we do 8421 again here. 8 plus 4, that's 12 plus 2, that's 14, which we just saw to be an E. Okay, so 14 is an E. So there you go. So that means your value here is going to be AE. You've done your working, now you write your answer. And you get 2 marks. This is so easy, right? The 2-bit binaries, add. Okay, we'll add. Okay, then calculate the least number of bits that can be used to store the number 301. Okay, well, let's work with that. Once they say bits, of course, this is binary, right? So this is binary. So you denary number 301 to binary, basically, would say that would be 128. 120, it's 1 times 2, that's 2 times 2, that's 4 times 2, that's 8 times 2, that's 16 times 2, that's 32, that's then 128. So this is a big number. This is something I'm going to have to teach you a lot. Okay, because we cannot have anything, you can't have anything above, you can't have anything that is going to be above 1. So the most that it can be is a 1s and 1s and 1s. So maybe let's put a star on it, then I'll tell you guys tomorrow. This is the last question, eh? This is the last question that we're going to do. Calculate the least number of bits. Also, we'd convert this to binary again. Let's see if we would do 301. Well, how much would it go? I'm sure you could keep going. If you say 128 times 2, you could keep going to get 256 and all these other things. You'd have bigger than that, I guess. What is 301 divided by 256? It is 1 remainder. Let's see. 301 divided by 256. Would get 1 remainder. Because if we had divided it by 108, we would get such a big number. Okay? If we had divided it by 1, we would get a big number. If we had said divided by 128, 301. That would be a problem, because you'd say 1 remainder. What is 301 minus 128? 10, 12. This becomes 10. This becomes 2. So this is 11 minus 8, that's 3. 10 minus 2, that's 8. 3 minus 2, that's 1. You'd get 183. Divided by that, that'll be just crazy. So we'd have to do 256. Divided by 256 now, it would be 301 minus 256. 11, this becomes 6. 11 minus 6, this becomes 5. 10, this becomes 3. 10 minus 6, this becomes 4. So now we have 45. So it's 1 remainder 45. So this is going to be 1. Then this would be 0, because 128 is bigger than 45, the new remainder. So until you get to 32, you'd put a 1 and say 32. So this becomes now 1 remainder 32. You'd get 13. 1 remainder 13. Okay? 1 remainder 13. Now you'd say, okay, 13, that's the new remainder 13. Is 16 smaller than 13? No. So you say 0. Is 8 smaller than 13? Yes. So you say you divide by 8. So here you put a 1, and here you get a 1 remainder what? You get 1 remainder 5. Is 4 smaller than 5 or equal to 5? Yes, it is. So we'll put a 1 here. So we would now say 5 divided by 4 would get a 1 remainder 1. So here you'd get a 1 remainder 1. Now you say 2 divided, that's going to be 0, and 1 into the last remainder, which is 1, is a 1. So you now have your answer 10101101. Okay, 1010 1101. Something like this. So this is what would be. Now let's see A4D now. Let's put A and 4 and a D. So we have an A. We are going to binary. We have a 4. We have a D. So what is A? We know that A is 10. So you put your 8, 4, 2, 1, and you should get 10. 10, you put 1 on 8 and 1 on 2. Then these other ones are 0. You have a 10 now. Then let's put the other one. The other one is 4. So for 4, how do you get a 4? You say 8, 4, 2, 1. It's like this. 0 on 8, 1 on 4, 0 on 0, and 0 here. Then we have a D. What is D? Class D is 13. So we now have 8, 4, 2, and 1. So how do you get 13? How do you get 13? Of course, you pick an 8, 1. Then if you pick a 4, that would be now 12. Then you put 0, you put a 1. That will be now 13. So it's like that. So now when we join, it will be 1, 0, 1, 0. Then 0, 1, 0, 0. Okay, then we say 1, 1, 0, 1. This is kind of what it would be. And you're good. That's going to be your answer. And we can just keep going on and on and on. But I'm proud of you people. Remember the number lines, okay? The number line when it's denary to binary is this. That's all we were using, okay? That's what we are depending on. Knowing the number lines. This one, then 8421 when it's binary to denary or whatever. That's how we are doing it. And we will be just using it. It's just varieties. I'm proud of you. Well done, everybody. Shuhaib, I'll check your message and that'll be it. Have you understood? Has everyone understood? If you are in the chat, please tell me if you have understood. Say I have understood if you have understood, everybody. If you are in the chat and you have understood how to do these conversions, please say you have understood if you are in the chat. Have you understood? Hello, if you're in the chat and you have understood, please say you have understood. Okay, well done, Elang. I can see you understood. Well done. Shuaib. Who else? Did everybody else understand? Okay, well done. Good, 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 good. So now what I just need to give is a few questions. I want to see you do questions. I'm going to give you questions. You have to do them. Then I mark and I see how you're performing, okay? So I'm going to send you the questions that I want you to do. You get to work, you do them, you send them back to me. I'm going to mark and I'll see how well you're doing. Well done. Goodbye for now. Let's stay in touch.